guys. It's just math, y'all. It's okay. You can do it. It's going to be fine. I promise. It's going to be fine. All right. Now, we're going to look at, in my good y'all voice, we're going to look at some piecewise functions. All right, let's do it. All right, so we're going to evaluate piecewise functions. Piecewise functions are functions. Can't see that, can you? Are functions that have two or more pieces. Okay, and each piece can be represented by an equation. Okay, and so, we have pieces of functions, not the whole part, just pieces of it. Now, this one is in two pieces, and I gave you the graph, and I color-coded it so you can see the two pieces. One piece is a pink piece, one is green, and the pink one has an equation, and the green one has an equation. Now, notice that this thing right here, this is confusing to people. I saw today, somebody calls that the handoff. That's where you have the handoff. That's where you switch from one function to the other function. And this one is where x is 2. And so, there's your x2, and we see that there's a handoff going on there. Okay? So we'll talk about that in a minute. But this is what a piecewise function looks like. It's in pieces. Now, you can have more than two pieces. 3 pieces is fine. But this is what it looks like. It is a function. Okay, remember the vertical line test? The vertical line test indicates that it is a function. Now, some people say, well, wait a minute. What about this vertical here at this handoff point of 2? Well, notice the different types of endpoints. This one has a solid endpoint, and the other one has an opened endpoint. Well, let's look at that. The pink one has a solid endpoint because it has an equal on it. It's the wrong color. Pink one is equal. There we go. It has an equal on it, and so that's why you have a solid there. The green one doesn't own 2. There's no equal there. It's just that's where it stops and starts. That's the handoff. But 2 does not belong to the green. There's no point there that belongs to the green. Okay? It's just microscopically close to that point. All right? And so that's the handoff point. And so that's what we have here. Okay? Now, that's just looking at one. Now, there's 2 things that we have to do for piecewise functions. One of them is evaluate them, which we're going to do in this video. And the other one is graph them, which is kind of like evaluating. But we can evaluate without the graph at all. We can evaluate without the graph at all. As a matter of fact, with the magic of erasers, let's evaluate these without the graph at all. You're like, yikes. Okay. So, let's talk about this particular function without the graph, because that's the way it looks a lot of times. First of all, we see this word if. Normally, if is at the beginning of our sentences, right? Well, they don't look like that in math. So in math, you might need to flip it around. Flip your if statement and see if it makes more sense. This is what it really says. It really says, if x is less than or equal to 2, then use 2x plus 3. And if x is greater than 2, then we use negative 3x plus 10. So we flip the if statement to make it make a little more sense to us, because all my students, they don't understand what that means. Okay? Again, I mentioned that's the handoff point because that's where it changes from one piece to the other. You saw that in the graph. But when it comes to evaluating, that's what you look at first. So let's go to evaluate. This first one says f of negative 2. Okay, so now remember, this is my x. So this one says f of negative 2. Is the x I'm using going to fit criteria number 1 or criteria number 2? Criterion number 1 says if x is less than 2, I'm going to use this formula. Oh, well, the number I'm looking at is less than 2, so I'm going to use 2x plus 3. And so I'm going to plug in negative 2 into that 2x plus 3. And I'm going to get negative 4 plus 3, which is negative 1. Let's do another one. 0. This time, is 0 less than 2? Absolutely. So I'm going to plug it into the first equation. Put the 0 in there. 2 times 0 is 0. 0 plus 3 is 3. All right. 2. Ooh. 2. They both have 2's. X is not less than 2. So maybe it's the second one. If x is great, no, it's not greater than 2. Wait a minute, let's look. It says, the first one says, if x is less than or equal to 2. This one is equal. The x I'm plugging in is equal to 2. So I'm going to plug into the first one. And I'm going to get 7. All right, so now the 4. My x is 4. All right, let's go to the first criteria. Is my x less than or equal to 2? Wait a minute, what's my x this time? This time, my x is 4. So no, it's not. So I go to the second one. Let's see, does it fit the second one? Is my x greater than 2? Ah, it is. So I'm going to use the second one. I'm going to use the second one. The second one says negative 3 times x plus 10. And I'm going to plug that in. And I get negative 12 plus 10 is negative 2. What about 8? Where do I plug in 8? Is 8 less than or equal to 2? No. Is 8 greater than 2? Yes. Then I'm going to plug it into the second one. And that's going to give me a negative 14, if I'm not mistaken. Check my math, I could be wrong. Okay, so that's what a piecewise function means. You got pieces, and you evaluate based on your criteria for your x. And because it's written second, so many students get confused. And here's the other thing. If I say, say I say plug in, let's say f of negative 7, and you give me 2 answers, you plug it into both of them, then I know you don't understand. Because if you understand, you know it only belongs to one of the 2, and you just have to pick out which one of the 2 it is. And if I were to do f of negative 7, well, negative 7 is less than 2, so I'm going to use the top equation. And I'm going to plug in 2 times negative 7 plus 3. And I'm going to get negative 11. Do not put it in the bottom because it does not fit. All right? Hopefully that helps. Now there is another video to come that is going to explain how to graph piecewise functions. Okay? So Look for that one coming up next. It's just math, y'all. You can do it.